Assalamu alaikum. In today's class we are going to learn the compound angle formula. Let's start. The first formula which we have to learn is sine of a plus b equals to sine of a cos of b plus cos of a sine of b. The second formula is with the negative sign. Sine of a minus b equals to sine of a cos of b minus cos of a sine of b. The third set of formula, the third formula is with cos. Cos of a plus b equals to cos a cos b minus sine a sine b. Fourth formula is cos of a minus b equals to cos of a cos of b plus sine of a sine of b. Okay, if you notice in the formula of sine, you have a positive sign here, positive sign here, positive sign here. It's a negative sign here, so a negative sign here. With the set of formulas with cos, if you have a positive sign here, you have a negative sign here, and if you have a negative sign here, you have a positive sign here. So you have to always be careful with this. Plus, if you also notice, in the formula of sine, you've got sine a cos b and cos a sine b here. But with cos, you've got both cos's here and both sines here. Okay, the next formula is with tan. Tan of a plus b is going to be tan of a plus tan of b upon 1 minus tan of a tan of b. And the last set of formulas, tan a minus b equals to tan of a minus tan of b upon 1 plus tan of a tan of b. With tan also, if you have a positive here, positive in the numerator but negative in the denominator, and if you have a negative here, then you have a negative in the numerator and then positive in the denominator. So you have to learn these six set of formulas, and let's see the application in the questions. Okay, it says expand and simplify cos of x plus 30. Okay, so we are going to use the formula cos a plus b. Okay, I am writing down the formula here so that you can relate to it. Cos of a plus b equals to cos of a cos of b minus sine of a sine of b. Okay, let's expand this. In this case, this is a and this is b. Okay, so it's going to be cos of x cos of 30 minus sine of x sine of 30. We know cos of 30 is root 3 upon 2 times cos of x, or you can even write cos of x first. So, I am writing cos of x into root 3 upon 2 minus sine of x into sine of 30 we know is half. So, if you take out this is going to become root 3 upon 2 cos of x minus half sine of x. Okay, so this is the answer. Moving on to, we just have to simplify it. We can't simplify it any further than this, so we just have to leave it. Moving on to question number 2. In question number 2, it says, without using a calculator, find the exact value of each of the following. Okay, if you notice in the first question, I am just copying the question. If you notice, they are using the formula of sine a plus b, sine cos cos sine. I am just writing down the formula sine of a plus b equals to sine of a cos of b plus cos of a sine of b. If you can just compare sine of a cos of b plus cos of a sine of b, it is equal to sine a plus b. So, in this case a is 20 and b is 70 degrees. So, it will become sine of 20 plus 70, which is actually sine of 90, and we know sine of 90 degrees is 1. So, the answer for this will be 1. Moving on to question number b part, I will be doing a few of these questions. Okay. So, if I do the b part, Okay, if you compare it with the formula sine of A cos of B minus cos of A sine of B is equals to sine of A minus B. So, in this case we know that A is 172 and B is 37. So, it will become sine of 172 minus 37, which is sine of 135 degrees, which is actually equals to, the basic angle is 45. So, sine of 45 and sine of 135 is the same. Sine of 45 is root 2 upon 2, which is the answer for this part. Moving on to if I just do the D part quickly. Okay, if you notice the formula which is being used here is cos here, sine here, that means it's cos of A minus B equals to cos of A cos of B plus sine of A sine of B. That means in this question A is 99 and B 69. So, it is equivalent to cos of 99 minus 69, which is cos of 30 degrees, which is actually root 3 upon 2. This is the answer for this part of the question. Now, I am doing question number F part. Okay. If you compare it to the formula tan of A minus B equals to tan of A plus tan of B. Okay, it should be a positive here. Okay, it should be a negative here, fine. Tan of A minus tan of B plus upon 1 plus tan of A tan of B. Okay, so if you compare it with this, the formula goes like this is equivalent to tan A minus B. In this case, A is 82 and B is 52. So, it is equals to tan of 82 minus 52, which is equals to tan of 30 degrees, and we know tan of 30 degrees is 1 upon root 3. I am not using the calculator because I have learned the basic formulas or the basic the sine, cos and tan of 30 degrees, 60 degrees and 45 degrees by heart. But if you do not know that, you can always use the calculator, and the paper calculator is allowed. Okay, moving on to this question. It says without using a calculator find the exact value of sine of 75. So, I can write sine of 75 equals to 45 plus 30, and we are familiar because we are not allowed to use the calculator in this question. That is why we know that sine of 45, we know the sine, cos and tan of 45, 30 and 60. So, I can write it as, if I solve it, it will become sine of 45 cos of 30 plus cos of 45 sine of 30. Okay. So, sine of 45 is root 2 upon 2, cos of 30 is root 3 upon 2 plus cos of 45 is root 2 upon 2 and sine of 30 is half. Let us simplify this. This will become root 6 upon 2 plus root 2 upon 2, which is 1 upon 2 times 6 root 6 plus root 2. This is the final answer, or you can even write it this way, root 6 plus root 2 upon 2. Okay. Moving on to tan of 75 degrees, the B part. Tan of 75 once again can be written as tan of 45 plus 30, and we know the formula is tan of 45 plus tan of 30 upon 1 minus tan of 45 tan of 30. Tan of 45 we know is a 1, tan of 30 is 1 upon root 3 divided by, so I am writing it like this, or if you want you can just write it in the denominator, whatever is convenient. So, if I write it in the denominator, it will be 1 minus tan of 45 is 1 and tan of 30 is 1 upon root 3. If I simplify this, if I take out the LCM of the numerator, I will get root 3 plus 1. If I take out the LCM of the denominator, I will get root 3 is the LCM. So, it will be root 3 minus 1. I can cancel this out with this out, and I will be left with root 3 plus 1 upon root 3 minus 1. Okay. Moving on to, if I want I can simplify it further. So if I just simplify it, root 3 plus 1 upon root 3 minus 1. So if I have rationalized the denominator, I have to multiply it by root 3 plus 1 upon root 3 plus 1. Okay. So this will become the numerator is going to be root 3 plus 1 the whole square upon root 3 square minus 1 the whole square. If I take it out, use the formula and open it, I am getting a 3 plus 2 root 3 plus 1 upon 2. So 4 plus 2 root 3 upon 2. If I divide both the sides, both the terms by 2, I will get a 2 plus root 3. This is the answer to the B part. Likewise, if I have to do, for instance, tan of negative 15, the D part. Tan of negative 15 is the same as tan of 30 minus 45. So I can apply the formula tan of 30 minus tan of 45 upon 1 plus tan of 30 tan of 45. Tan of 30 is 1 upon root 3, tan of 45 is 1 upon 1 plus tan of 30 is 1 upon root 3 and tan of 45 is 1. We can just simplify it the normal way, the way we simplified it here, taking out the LCM and then rationalizing the denominator, and we'll get the answer. Okay. So moving on to question number 3, say the E part, sine of pi by 12. Okay, first of all, what I am going to do is, I know pi is equivalent to 180. 180 divided by 12 is 15. So it is in degrees equal to 180 divided by 12, which is 15, and 15 I can get by 45 minus 30. So the equivalent of 45 in radians is pi by 4, and the equivalent of 30 is pi by 6. So I am going to make it into sine of pi by 4 minus pi by 6 and apply the formula sine of 45 minus sine of sine, I am just writing down the formula, sine A minus B equals to sine of A cos of B plus cos of A sine of B. Okay, so I am applying the formula sine of pi by 4 cos of pi by 6 plus, sorry, negative sign here, it should be a negative sign here. Okay, minus cos of pi by 4 into cos of into sine of pi by 6. Let us simplify. Sine of pi by 4 is 2 upon under root 2 upon 2. Cos of pi by 6, pi by 6 is equivalent to 30. So cos of 30 is root 3 upon 2. Minus cos of pi by 4 is root 2 upon 2, and sine of pi by 6 is half. Pi by 6 is 30 and sine of 30 is half. Okay, let us simplify this. Root 6 upon 4 minus root 2 upon 2. If I take out the LCM, root 2 upon 4. Okay, don't need to take out the LCM because the denominators are the same now. So root 6 minus root 2 upon 4. This will be the final answer. Okay. Likewise, you can do the rest of the questions. I am doing the G part. Cot of 7 pi by okay, so I am doing this cot of 7 pi by 12. First of all, I am going to change it into its equivalent. Pi is equals to 180 divided by 12. 12 1 times, 12 15 times. 15 7 times I know is a 105. Okay, and 105 is equivalent to 60 plus 45. So I am going to write and 60 is equal to pi by 3 and 45 is pi by 4. Okay, so I can write it as cot of pi by 3 plus pi by 4. I'm going to use the formula for tan. Tan, if I'm just writing out the general formula first. Tan of A plus B equals to tan of A plus tan of B upon 1 minus tan of A tan of B. Okay, now if it's a cot of A plus B, we know that cot is a reciprocal of tan. So, this will go up and this will come down. You have to reciprocate this side as well. So, it will become 1 minus tan of A tan of B upon tan of A plus tan of B. Okay, 1 minus tan of A, that means tan of pi by 3. In this question, we will take A to be a pi by 3 and a B to be pi by 4. Okay, tan of pi by 3 into tan of pi by 4 upon tan of pi by 3 plus tan of pi by 4. Okay, let's simplify this. Tan of pi by 3, tan of 60 is root 3, tan of 45 is a 1 upon tan of 60 is a root 3 plus tan of 45 is 1. So, 1 minus root 3 upon root 3 plus 1, rationalize it, root 3 minus 1. When we have to get rid of the denominator, this third from the denominator, whatever is the sign in between the two terms, we change it and make it into its opposite sign and we call it the conjugate. So, this is the conjugate of this. So, we are going to multiply it by the numerator as well as the denominator. Okay, let's simplify this. It's 1 minus root 3 into root 3 minus 1. So, I can write 1 into root 3 minus 1 minus root 3 into root 3 minus 1 upon root 3 square minus 1. This will become root 3 minus 1 minus 3 plus root 3 upon 3 minus 1, which is 2. Okay, it becomes 2 root 3 minus 4 upon 2. When you divide both the terms by 2, you will get a root 3 minus 2. This is the final answer to this part, which was actually the G part of question number 4. Okay, moving on to the next question, which is question number 4. Yeah, cos of x equals to pi by 4 and x lies between 0 and 90. Okay, so I'm just making the diagram. It's an acute angle. So, cos of x is adjacent upon hypotenuse. So, adjacent is this, hypotenuse this, and if you apply Pythagoras theorem, you get x, the opposite side as 3. Now, cos of x is 4 upon 5. Without using a calculator, find out the exact value of cos of x minus 60. So, I am using the formula here, cos of x minus 60 equals to cos of x cos of 60 plus sin of x sin of 60. Okay, cos of x we know is 4 upon 5. Acha, if I just use this diagram and if I find out sin of x here, sin of x is opposite upon hypotenuse, which is 3 upon 5. Okay, cos of, I am just continuing from here, cos of 60 we know is a half, sin of x here is, I have just calculated it to be 3 upon 5 and sin of 60 is root 3 upon 2. Let us simplify 4 upon 10 plus 3 root 3 upon 10. It will become 4 plus 3 root 3 upon 10. This is the final answer to this question, question number 4. Moving on to question number 5. They are saying given that sin of A is 4 upon 5 and sin of B equals to 5 upon 13, where A and B are acute, show that A plus B equals to this. Okay, so if I use the first diagram in order to find out because they've told us that it's acute, so I'll make it in the first quadrant. If this is A, sin of A is 4 upon 5, that means the opposite is 4 and the hypotenuse 5, and so this is 3. Likewise, I'll make another diagram for B, where I will make an acute angle here. I am going to call that acute angle as B. Okay, they are saying sin of B is 5 upon 13, that means opposite upon hypotenuse is, if you apply Pythagoras theorem, you will get 12. Okay, this is a very common Pythagorean triple, 3, 4 and 5 and 5, 12 and 13. So, if you know the hypotenuse and the opposite, you can easily find out. This is one very known commonly known Pythagorean group, 3, 4 and 5, and the other one is 5, 12 and 13. So if you learn this, you don't have to even apply Pythagoras theorem to get to the third unknown side. Okay, we have to find out you have to show that sine of a plus b equals to this. Okay, let's apply the formula. Sine of a plus b equals to sine of a cos of b plus cos of a sine of b. Okay, sine of a is 4 upon 5 and cos of b is 12 upon 13. Cos of a is 3 upon 5. Sine of b is opposite upon hypotenuse 5 upon 13. Simplify this, 48 upon 65 plus 15 upon 65, which is 63 upon 65. This is proved. We just have to prove it. Let's move on to this question. Question number 7. It says cos of a equals to negative 4 upon 5 and sine of b equals to negative 8 upon 17. Okay, where a and b lie in the same quadrant. Now you have to think about the quadrant. Cos is negative in the second and the third quadrant. So I'm just writing down the possible quadrants, second and the third quadrant, and sine is negative in the third and the fourth quadrant. And since they are saying that both of them lie in the second quadrant, so the common quadrant here is third quadrant. So I'm making that diagram in the third quadrant first of all. Cos of a is adjacent upon hypotenuse, so obviously it's going to be a 3, and sine of b is negative. This is for a. The second diagram which I am going to make is for b. It's just a rough diagram. Sine of b is opposite upon hypotenuse, which is here. Okay, so I've got both the diagrams now. Now with the help of, if I just do one part, I'm doing this part, the last part of this, tan of a minus b. Let me write down the formula first. Tan of a minus b is tan of a minus tan of b upon 1 plus tan of a tan of b. Okay, if I just find out tan of a from here, tan of a is 3 upon 4 and tan of b is, if I apply Pythagoras theorem here, this is going to give me a 17 square minus 8 square. Okay, which is 15 here. So I'm writing 15. Okay, tan of b is going to be 8 upon 15. Fine. So just applying in the formula, tan of a is 3 upon 4, tan of b is 8 upon 15 upon 1 plus tan of a is 3 upon 4 and tan of b is 8 upon 15. Let's solve it. Okay, so I'm using the calculator and getting 3 upon 4 minus 8 upon 15, which is 13 upon 16, the numerator. In the denominator, if I solve this part, I am getting a 7 upon 5. Okay, dividing the 2. I am getting a 13 upon 84. This is the answer to the last part of the question, tan of a minus b. Likewise, we can do the rest of the two parts also. Okay, moving on to question number 8 now. Okay, it says given that tan of a equals to t and that tan of a minus b equals to 2. Find tan of b in terms of t. Okay, tan of a equals to t, so I am just making the diagram. I'll take it to be the first quadrant. I'll just make the diagram. Opposite upon adjacent. So if this is a, opposite is t and adjacent is 1. So I can apply Pythagoras theorem and get this. Although we don't need this. If in case we'll feel that we need it, then we'll find it out. Tan of a minus b equals to 2. Okay, let's use the formula. Tan of a minus b equals to tan of a minus tan of b upon 1 plus tan of A, tan of B. Tan of A is t, tan of B is what we have to find out. So, I am calling it as x upon 1 plus tan of A, which is t, and tan of B, which is x, and they have told us that tan of A minus B equals to 2. So, it is equals to, the whole thing is equals to 2, cross multiply 2 plus 2 t x equals to t minus x. We have to find out tan of B, that means we have to make x the subject, we have to find out the value of x. Okay, so I am writing 2 t x plus x equals to t minus 2. Okay, if I take out x as common, I will be left with 2t plus 1 equals to t minus 2, x equals to t minus 2 upon 2t plus 1. This is the final answer to this question, which is the 8th question. Okay, moving on to this question. If cos of A minus B equals to this, find the exact value of tan of A, tan of B. Okay, let's expand this first. Cos of A minus B. Cos of A minus B is equivalent to cos of A, cos of B plus sine of A, sine of B equals to 3 times cos of A plus B. Okay, so it's going to be cos of A, cos of B minus sine of A, sine of B. Okay, let's simplify because we have to find out the value of tan of A, tan of B, and tan is sine upon cos. So we have to do something so that sine comes in the numerator and cos goes in the denominator. Let's simplify. Okay, if I solve this part, I'll get 3 cos of A, cos of B minus 3 sine of A, sine of B. Okay, on this side I've got, I'm going to shift all the terms with cos A, cos B on one side now. So, I am just rewriting this, copying it from the previous step, sine of A, sine of B. Okay, I am keeping all signs on this side. So, I am writing sine of A plus sine of B plus 3 times sine of A, sine of B equals to 3 times cos of A, cos of B minus cos of A, cos of B. Okay, now if I add them up, sine of A, sine of B plus 3 sine of A, sine of B, that means this will become 4 sine of A, sine of B equals to 3 minus 1 is 2 cos of A, cos of B. Okay, if I bring sine A upon cos, this whole thing in the numerator and this in the denominator, so it will become sine of A, sine of B upon cos of A, cos of B equals to 2 upon 4. This 4 is going to go down in the denominator on this side. Okay, this will become tan of A, tan of B, because tan is actually sine upon cos. Okay, equals to 1 upon 2. You have to find out the value of tan of A, tan of B, which is half. So, the answer is going to be half. Question number 10 now. Given that 8 plus cosec square theta equals to this, find the value of tan of theta, the first part. Okay, so I can apply the second identity, which I know is, I am writing it down here, 1 plus cot square theta equals to cosec square theta. Okay, in place of cosec square theta, I am going to plug in cot square theta, 1 plus cot square theta, so that the whole equation is now in terms of cot square theta. So, let us start. It will become 8 plus 1 plus cot square theta equals to 6 times cot theta. Okay, let us simplify and open the bracket. 8 plus 1 plus cot square theta equals to 6 cot theta. All the terms with on one side, cot square theta minus 6 cot theta plus 9 equals to 0. Let y equals to cot theta. So, this will become y square minus 6y plus 9 equals to 0. If I factorize, it will become y square minus 3y minus 3y plus 9 equals to 0. So, y is common, y minus 3 minus y, y minus 3, sorry, minus 3 is common, or you can factorize it directly with the formula a plus b the whole square equals to a square minus 2ab plus b square. Okay. So, I have got two brackets of y minus 3 now. So, the answer for y is a 3. What was y? It was cot theta. So cot theta equals to 3. So obviously tan theta is going to be 1 upon 3. Positive, so you have to look for it in the first and the third quadrant. I am doing tan theta of tan inverse of 1 upon 3 here. I'm solving it. Angle should be in radians, so sorry, degrees. Tan inverse of 1 upon 3. 18.43 is the basic angle. 18.43. So in the first quadrant it will be 18.43, and in the third quadrant it will be 18.43 plus 180, which is 198.43. So the answer for theta is going to be up to 3 significant figures, 18.4 and 198.4 degrees. This is the first part done. Hence find the exact value of tan of theta plus 45. Okay. 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 They had asked for the, they didn't ask for the angle. Basically, I didn't have to find out the angle. It was just asking for the exact value of tan of theta. So I just had to stop there. Tan of theta is 1 upon 3. So I didn't have to find out the angle. Okay, so I had to actually stop here. They didn't ask for the angle. They asked for the value of tan of theta, which is 1 upon 3. Okay, the second part, hence find the exact value of tan of theta plus 45. Okay, the B part, tan of theta plus 45. Let's apply the formula. It will become tan of theta plus tan of 45 upon 1 minus tan of theta, tan of 45. We know tan of 45 is a 1, so it will be tan theta plus 1 upon 1 minus tan of theta, because tan of 45 is 1. Tan of theta we know is 1 upon 3, so 1 upon 3 plus 1 upon 1 minus 1 upon 3. Let's simplify this. 4 upon 2, which is actually 2. So the answer for this is going to be a 2. Okay, let's move on to the next question. Question number 11. Given that x is acute and that sec square theta, sec square x plus 7 tan x equals to 17, find the exact value of tan of theta. It's similar to that question, so you can apply the second identity here. So I'm writing down the second identity in the corner here. 1 plus tan square theta equals to sec square theta. So in place of sec square theta, I'm going to write 1 plus tan square theta. So 1 plus tan square x plus 7 tan of x equals to 17. Let's simplify it first, and then we're going to take tan x as y. So 2 plus tan square x plus 7 tan x equals to 17. So this will become, let y equals to tan x. So 2 plus y square plus 7y minus 17 equals to 0. Y square plus 7y minus 15 equals to 0. Breaking the middle term, y square plus 5y okay, I made a mistake here. It was 2 plus 2 tan square theta, tan square x. Okay. Okay, so let's just make that change. This will become 2 plus 2y square plus 7y minus 17 equals to 0. 2y square plus 7y minus 15 equals to 0. Breaking the middle term, so 2y square, if I make it into 10y minus 3y minus 15 equals to 0. If I am subtracting, I am getting this. If I am multiplying, I am getting a minus 30. Okay. If I take out 2y as common, it will be y plus 5. If I take out minus 3 as common, y plus 5 equals to 0. Okay, so 2y minus 3 is the first bracket and y plus 5 is the second bracket. One answer is y equals to 3 upon 2 and the other answer equals to y equals to negative 5. Y is tan of x. Okay, find the exact value of tan of x. Tan of x is 3 upon 2 and tan of x is negative 5. Since they are saying theta is x is acute, so acute angle you will get from here, because here you're going to get the obtuse and the reflex angle, because tan is negative in the second and third fourth quadrant. So we will take this one. So the answer is going to be tan of x equals to 3 upon 2. Hence find the exact value of the b part. Tan of 225 minus x, so I am going to apply the formula. 225 minus x is going to be tan of 225 minus tan of x upon 1 plus tan of 225 tan of x. Tan of 225, the basic angle is 45, tan of 45 is 1, and this lies in the third quadrant. In the third quadrant also tan is positive, so it was going to be 1 only. 1 minus tan of x. Tan of x we know is 3 upon 2 divided by 1 plus tan of 225 is 1, 1 into tan of x, which is 3 upon 2. Let's simplify this. 1 minus 1, 1 and a half is a minus half upon 1 plus 1 and a half is 5 upon 2. So when you simplify, you get a minus 1 upon 5 as the final answer for question number 11. Okay, moving on to question number 12. Show that the equation sine of x plus 30 equals to 5 cos x minus 60 can be written in this form. Okay, let's expand this. Just copying this. Okay, so this can be written as sine of x cos of 30 plus cos of x sine of 30 equals to 5 times, it will be cos of x cos of 60 plus sine of x sine of 60. Okay, we know cos of 30 is a negative under root 3 upon 2. So under root 3 upon 2 sine of x plus sine of 30 is half. So I am writing half cos of x equals to 5 times cos of 60 is half. So cos of x plus sine of 60 is root 3 upon 2 sine of x. Let's simplify this. Okay, I am going to bring all the terms with sin x to one side and all the terms with cos x on that side. So root 3 upon 2 sine of x plus half cos of x equals to 5 upon 2 cos of x plus 5 root 3 upon 2 sine of x. All sine of x on one side, root 3 upon 2 sine of x minus 5 root 3 upon 2 sine of x equals to 5 upon 2 cos of x minus half cos of x. Okay, if I solve this, root 3 upon 2 minus 5 root 3 upon 2, it is giving me minus 2 root 3 upon 2 sine of x equals to 5 upon 2 minus half. So 2.5 minus half is 2 cos of x. Now if I am going to bring, because I have to make it into cot x, so cos x under sin x. So this will become cos of x upon sine of x equals to minus 2 root 3 upon 2. So I have got cot of x equals to negative root 3. This is what I had to prove in the first part of the question. In the second part, hence solve the equation. Now if you compare it to this, it's exactly the same as what it was written. So in place of this, I can write yes. In place of this whole thing, I can write cot of x equals to negative 3, negative root 3. Cot of x equals to negative root 3, and I have to find out the angle from negative 180 to 180. So I am going to reciprocate both the sides. I will get cot of x, I will reciprocate it, I will get tan of x, and if I reciprocate this side, I will get this. The basic angle which I am going to get is 30 degrees. Okay, tan is negative in the second and the fourth quadrant. Okay, if I look at the second quadrant, on the negative side, in the negative side, if you notice, this is up to 180, so it is not going into the second quadrant, but in the positive side it will be 180 minus 30, which is a 150. So the answer is going to be 150. And just hold on, negative 150. Acha, one more thing is that because the basic angle is 30 and I have to look into the on the negative side I have to start from 0 till negative 180. So negative 30 comes in this, because you have to look in the fourth quadrant as well. So one answer is going to be negative 30 and 150. So yeah, on the negative side you get this angle, on the positive side you get this angle. Okay, starting with the next question now. Solve each of the equation for x is greater than or equal to 0 and less than or equal to 360. So I can just do two of these. I can do the A part and the D part. Okay, for the A part, cos of x plus 30 degrees equals to 2 sine of x. I can apply the double angle identity here. It will become cos of x sine of 30 plus, sorry, cos of x cos of 30 plus sine of x, negative sign, because in case of cos, if it is a positive in the middle, you have a negative here, sine of x sine of 30 equals to 2 sine of x. Let us solve this. Cos of 30 is root 3 upon 2 times cos of x minus sine of 30 is half times sine of x equals to 2 sine of x. If I bring all the terms with sine x on one side, so 2 sine of x plus half sine of x will become 5 upon 2 sine of x equals to root 3 upon 2 cos of x. Okay, if I bring sin x, cos x underneath sin x, I will get tan of x, and root 3 upon 2 divided by 5 upon 2. This will become tan of x equals to root 3 upon 5, since it is positive. So first and the third quadrant you have to look into. I am finding out the basic angle, tan inverse of root 3 upon 5. The basic angle is 19.1. Okay, so in the first quadrant it is going to be 19.1, in the third quadrant it will be 180 plus 19.1, which is 199.1. You have to give the answer up to one decimal place for angles and degrees. Okay, the last part, let me do this one because I have done one with cos, I am doing one with sine now, or I can use this one, the D part. Okay, this can be written as cos of x cos of 30 to, if I expand this, I will get sine of x cos of 60 plus cos of x sine of 60. Okay, cos of 30 we know as root 3 upon 2. So root 3 upon 2 cos of x equals to 2. Cos of 60 is half sine of x plus sine of 60 is root 3 upon 2 cos of x. Okay, so we are going to bring, first simplify. So this 2 will simplify this as well as this. So you are left with root 3 upon 2 cos of x equals to sine of x plus root 3 into cos of x. Okay, all the terms with cos on one side. So root 3 upon 2 cos of x minus root 3 upon cos of x, root 3 cos of x equals to sine of x. Root 3 upon 2 minus root 3 is minus root 3 upon 2 cos of x equals to sine of x. This will become tan of x equals to, this cos x is going to go in the denominator here, equals to negative root 3 upon 2. We have to look for it in the second and the fourth quadrant because tan is negative in the second and the fourth quadrant. So let's find out the basic angle. Tan inverse of root 3 upon 2, 40.8. Basic angle is 40.89. Okay, for the second quadrant the angle is going to be 180 minus 40.8, which is 139.1, and for the fourth quadrant it will be 360 minus 40.89, which is 319.11. These are the two answers for the D part. Okay. Okay, moving on to question number. Okay, let me just check one thing in this. Okay, I made a mistake here. I solved this with the double angle formula, but I didn't solve this on this side with the double angle formula. It will be cos x cos 30 minus sin x sin 30. So just let me just quickly fix it this side. Okay, this will become cos of x cos 30 minus sin of x sin of 30. Cos of 30 is root 3 upon 2 cos of x minus sin of 30 is half sin of x. Okay, now I'm going to shift all the terms with sin x on one side. So sin of x plus half sin of x equals to root 3 upon 2 cos of x minus root 3 upon cos of x. Okay, 1 plus half is 1 and a half, that means 3 upon 2 sin of x here, and root 3 upon 2 . This is negative root 3 upon 2 cos of x here. Sin x upon cos x is tan of x equals to negative root 3 upon 2 upon 3 upon 2. Okay, so you've got tan of x equals to negative root 3 upon 3. This is 30. Okay, so you have to look for it in the second and the fourth quadrant. Okay, so basic angle is 30, second quadrant will be 150, and fourth quadrant is going to be 330. These are the two answers for the last part of question number 30. Okay, I'm just going to do one question from here, maybe this one, the C part. Sin of x plus 60 equals to 2 times cos of x plus 45. Okay, I'm going to split it. Sin of x cos of 60 plus cos of x sin of 60 equals to 2 times, I'm going to apply the formula of double angle on cos, cos of x cos of 45 minus sin of x sin of 45. Let's simplify. Cos of 60 is half, so half sin of x plus sin of 60 is root 3 upon 2 cos of x equals to 2 times cos of 45 is root 2 upon 2 cos of x minus sin of 45 is root 2 upon 2 sin of x. Okay, let's put all, this 2 is going to cancel out these 2. So all sin x on one side, half sin x plus root 2 sin of x equals to root 2 cos of x minus root 3 upon 2 cos of x. Okay, half plus root 2 is going to be 1 plus 2 root 2 upon 2 sine of x equals to root 2 minus root 2 minus root 3 upon 2. Okay, this is minus root 3 plus 2 root 2 upon 2 cos of x. I am going to bring both of them on one side. Sin x upon cos x is tan x, and I am going to divide this by this. So, I am writing it minus root 3 plus 2 root 2 upon 2 divided by 1 plus 2 root 2 upon 2. 2 and 2 will cancel out. So, I am just making the fraction now, minus root 3 plus 2 root 2. Okay, divided by 1 plus 2 root 2. This is 0, tan of x equals to 0.286 positive. So, I have to look it into the first and the third quadrant. The basic angle is 15.98. So, in the first quadrant it will be 15.98. 15.98 is 16.0 actually. And for the third quadrant it will be 180 plus 15.98, which is 195.98, so 196 up to 1 decimal place. Okay, these are the two answers for question number 14. Okay, you have to find out the angle up till 180 only, so you don't have to take this angle, you just have to take the first one. This was the answer. Okay, question number 15. Okay, solve the equation. Tan of x minus 45 plus cot of x equals to 2. So, I am going to split this into the double angle identity. Tan of x minus tan of 45 upon 1 plus tan of x tan of 45. Okay, plus cot of x is cos 1 upon tan x equals to 2. Let us simplify this as tan of 45 is 1. So, it will become tan of x minus 1 upon 1 plus tan of x plus 1 upon tan of x equals to 2. Okay, if I take out the LCM, I will get tan of x into 1 plus tan x. Okay, this will become okay. If I take out the LCM, it will be tan of x into 1 plus tan x. So, this will be multiplied by tan x. So, tan x into tan x minus 1 plus 1 plus tan x equals to 2. Let us simplify. Tan square x minus tan x plus 1 plus tan of x equals to 2 times, if I cross multiply, tan of x plus tan square x. Okay, this and this will cancel out. You are left with 1 plus tan square x equals to 2 times tan x plus 2 tan square x. All the terms on one side. So, 2 tan square x minus tan square x plus 2 tan x minus 1 equals to 0. So, this will become tan square x plus 2 tan x minus 1 equals to 0. If I take tan of x as y, y plus 2y minus 1 equals to 0. So, it will become if I take a as 1, b as 2 and c is negative 1 and apply the quadratic formula. So, the answers are y equals to negative 1 plus root 2, and negative 1 minus root 2. Okay, y was taken as tan of x. So, I am going to write tan of x equals to minus 1 minus plus root 2, and tan of x equals to minus 1 minus root 2. Okay, the decimal value is tan of x equals to negative, decimal value of this is minus 2.41. Okay. And this decimal value is 0.41. Okay. This is in the first quadrant, positive, so first and the third quadrant. I am taking out the basic angle now. Tan inverse of 0.414, 22 point. We don't have to look for it in the third quadrant because you just have to find out the acute and the obtuse angle first and the second quadrant only. So, I am just going to write first quadrant here because it is positive. Tan is positive in the first quadrant. So, basic angle is 22.4. So, the answer is going to be 22.4 here. 22.48 has, so you just have to take it as 22.5, and in this case since it is negative, so you have to look for it in the second quadrant. Basic angle is going to be tan inverse of 2.41, it's 67.5. So, the angle is going to be 180 minus the answer, which is 112.5. These are the two answers, 22.5 comma 112.5 degrees. Okay. The last question, use the expansion of cos of 5x plus x and cos of 5x minus x to prove that cos of 6x plus cos of 4x is equals to this. Okay, so I am just copying this first. Cos of 6x is equals to cos of 5x plus x, and cos of 4x is cos of 5x minus x. Okay. So, in place of this I have written this, and see I have to simplify it and prove that it is equals to this. So, I am going to apply the double identity for cos. So, it will be cos of 5x cos of x minus sine of 5x sine of x. This is the first one, plus cos of 5x cos of x plus sine of 5x sine of x. Okay. If I open it, it will become, this is positive and this is positive. So, it will become 2 times cos of 5x cos of x, and this is negative and this is positive. So, these two will cancel out. So, I have got what they had asked us to prove. Okay, so it is proved. Okay, thanks a lot for watching the video. Hope you have learnt the double angle identity.